in the last 20 minutes or so here now, the full day tomorrow, and the half day on Friday. That won't be a big deal for us to get through this. That's usually about the time it takes to go. What I'm looking at here today is that you guys have already done a whole bunch of factoring, but what we're going to start to do is we're going to start to factor higher degree polynomials. You guys have basically factored quadratics or done just simple GCF problems. For example, excuse me, you guys factored this. A difference of squares, right? X squared minus 4. X squared is a perfect square, 4 is a perfect square, and that's a what symbol between the two?
Minus.
Subtraction symbol. So what would be your two terms if you factored that? Okay. Your two terms would have been x plus 2 and x minus 2. On the other hand, we also looked at stuff like this, where it was x squared plus 9, and we would try to factor that. Could we?
No,
Why?
it's positive.
Yeah, it's positive between the two. So we would say it was unfactorable. And we learned more about that later on, is when we started to set that equal to 0, you'd wind up with imaginary solutions. Remember that? So what we're going to do then is we're going to take that next step. We're going to take it a step further. Instead of talking about quadratics, we're going to talk about cubics. We're going to look at x cubed plus 8. Okay. Now I'm talking about cubes, perfect cubes. And we've done, yeah, you got that song stuck in your head. We've talked about perfect squares, 1, 4, 9, 16, 25, 36, and so on. When we're looking at perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 4 cubed.
64.
64. 4 cubed is 64, 5 cubed is
3,000 something.
125.
Close.
6 cubed goes to 16. 7 cubed is something that ends in a 3. I think it's 343.
Yeah.
Now, to be honest with you, bless you, if you know your first 5 or 6 perfect cubes off the top of your head, you're going to be fine. Okay? A lot of these, they don't get much larger than that. If it's anything larger than that, you're going to wind up with a calculator. But if they're within the first 6 or so, you're going to be okay without one. All right? So in this case here, we're going to do factoring of what's called a sum of perfect cubes, and we're going to do a difference in cubes. We're going to do the same. I'm going to do it for both of these. Okay? There is a special pattern that occurs for when you're working with cube roots, and it looks like this. Oh, let me put this up. When we're doing cubes, first thing we're going to identify is whether or not the first term is a perfect cube or not. So does it fall into the pattern of a cubed plus b cubed for that one? Is x cubed a perfect cube? Is 8 a perfect cube?
Yeah.
Okay. So since that's going to work, this is going to equal the following pattern. A plus b times the following. First term squared minus the 2 terms multiplied together plus the last term squared. Okay. The sum of cubes will always follow that pattern. If the first one is a perfect cube, it's playing the role of A. If the second one is a perfect cube, it's playing the role of B. So if this example, x cubed plus 8, I would simplify that to be x cubed plus 8. What's the cube root of x cubed?
X.
What's the cube root of 8?
2.
2. You go x plus 2. First term squared, you get? The last term is going to be plus 4. Everybody okay with that? Yeah. And then the middle term, you wind up just taking the 2 terms and multiplying them together. Minus 2x. And that's your factored form. Now, the other classes have asked, well, can't I go further? Can I factor that trinomial? Well, what times what would be a positive 4 that you would add together to get negative 2? Nothing. It's unfactorable. You'd have to use quadratics or something along those lines. So you're done. Well, you don't want to, you're not completing the square because you're not equaling 0. Okay? We're not solving for solutions here. We're not solving for zeros because there's no equal sign. All we're doing is just factoring. Okay. It implies that. How's that? So when you have these two patterns, you have the factored form of this, a plus b, a squared minus ab plus b squared. And then when you do that with the subtraction, I'm going to change this to a different number for the subtraction. I'm going to change it to x cubed minus 27. Is it okay to change it to that? That way you don't get pigeonholed into the 8s.
Okay.
What's the cube root of 27?
3.
3. All right. So we've already said that this follows the pattern of a cubed minus b cubed. When you factor that, you once again will have two separate, you'll have a binomial and a trinomial. The first one is going to be a minus b. The second one, a squared, now it changes it, plus ab, and then plus b squared. And when you work with these patterns, these two patterns, this is one of the sections or one of the things that I struggled with in high school when I was factoring the cubes like that, because I always forget what the signs are doing. Over time, we kind of came up with kind of the easiest way to remember this. See if you guys notice it. See if you notice what's going on here.
A minus B.
If it's a plus, it goes plus minus plus. Notice how these guys are the same?
Yeah.
Then it switches, and then it's always positive. These guys are the same, switches, always positive. So when you start to break these things apart, it just takes a little bit of practice to get accustomed to the pattern that goes on. But once you start to recognize the pattern that if it's a difference of perfect cubes, the first binomial would be negative, then it switches signs. Okay. So let's walk through the x cubed minus 27. X cubed minus 27 would give me what in my, as for the binomial? X minus 3. And then what goes into the trinomial then?
X squared.
X squared plus 3x. Very good. And it fills in just like that. Now, it's really nice and easy when it's a singular term, x and a 3. What you're going to screw up, like you guys did when you had to distribute the binomial stuff,
Yeah.
is if it looked like the following.
Oh, goody. Is it going to be a leading term?
Yep.
Why can't it just stay easy, like this one? Why can't it just one stay easy?
What's going to happen here is your first term is an 8, so it's 8x cubed and a 27. Is 8 a perfect cube?
Yeah.
Is x cubed a perfect cube?
Yeah.
So what would be the cube root of 8 to x?
2x.
It would be 2x. Okay. So here's what happens when you factor this out. We know it's going to be the pattern a cubed minus b cubed. That's going to equal first minus second, first one squared, plus the two of them multiplied together, plus the last one squared. Okay. When I start to peel out what the a value is actually equal to in this case, remember, the a value here is 2x. Okay? The a value is 2x, whereas the b value now is 3. And Jessica, this is what you were doing. It's the quantity 2x squared. Okay? Because the a value is 2x. So when I square that, 2x quantity squared, what do you get? 4x squared. Am I right?
Yeah.
This is why I want to point this out here. You get 4x squared. The next term is going to be, was it going to be positive or negative? Positive, what will it be, Ellie? Very good. And then what's the last one? Plus 9. What you guys will mess up is whenever you have that leading term coefficient that's not equal to 1. That's where you'll mess that up. Yeah.
Wait, why is it minus 6?
Oh, I get it, we got squared.
We start with the, since we started with the minus, the next one we minus, then it goes plus.
Well, it's the a2x and then do we leave the minus out of it then? Oh wait, so if it was minus -3, then the b would be -3.
Yeah, if it was minus and negative, then we would just write it as plus. Don't overcomplicate. All right, so try this. Swing Pensado. Okay, pensado I think is higher.
Yeah.
Lo siento. Say nada. Lo siento. You're welcome. I'm sorry. You're welcome. I'm sorry I kicked you. You're welcome.
It's just weird you can do the same thing. It's okay. And then it's okay. And he says you're welcome. You just gotta think of it.
Yes, I teach math. Anywho, in this case here, is 64 a perfect cube? Yes. I know I see some of you guys searching on your calculator to help check these things. Do you know how to find the cube root button on your calculator?
Yeah.
How?
Reduce.
Hit the button that says math, and then you'll have a cube root function.
That's math folder.
Math. 4. 64.
Oh, this is an addition. You're fine. This is how your first term looks like it. Oh, 4x. Oh, you're asking. Yes. So, our first grouping here, hopefully you guys are on your way.
Yeah.
4x plus 2y.
That's what I got.
Yeah.
So now I square that first term, you get what?
16x squared.
16x squared. I know it's got to be a minus sign because it's going to alternate my sign now. 8xy, put them together. 8xy. And then I square the last one, you get? Plus 4y squared. So it's not that scary, is it?
No.
Okay.
Wait.
Why do you always think that?
Because I know you're going to mess with us eventually.
Well, yeah, it's kind of my
It's
job.
going to give us well, then you can't act like
I don't know if 54 is.
you can't say I'm wrong. No, it's like, oh wait, time out.
Yes, sir.
Do we have to like, if we're simplifying, we write like the other ones, you would write something radical. Do you have to write something square radical and like, or can you simplify it down?
When we get to that point, I'll show you.
Okay, I thought that, isn't that what we don't do?
No. Yes, ma'am. Now, going back to what I just had up there, neither one of those is a perfect cube, is it? No. How can I turn them into one? Clay knows. Will somebody please call on Clay so he stops breaking things? Anybody but no. What do we have to do, Clay?
GCF of 2.
GCF 2.
That's the one thing I did right.
What's going to happen with these types of problems, we kind of did a little bit of this every once in a while before. Sometimes you have the perfect cube roots hiding within them. You need to have them show up. Now, we've talked about this in the earlier classes today. what do I do with that 2 now?
And just get rid of it.
Do you see an equal sign? Am I solving for zeros?
You just
I have to remember to bring this down, right. In this case here, since I'm not solving for my x value, I'm not solving for x, I'm factoring. When I'm factoring, this 2 comes along for the ride. And that'll be what, 9x squared. The 2 wants a little adventure as well, okay? It's not like getting the GCF of one of the quadratics and then you would divide out because you were on your way to solving for zeros. In this instance, since we're just factoring, sometimes you just have to pluck it out and go. We can't get rid of it though, that's mean.
No one likes to.
If I say I don't like you, do I get scared of you?
Yeah.
Good, but you have to make it look like
I do
an
like
have a guy for that.
You got me. On a technicality.
You have to make it look like an
You can exit, yeah. Do this one.
Okay.
Wait, what'd you factor out?
2u squared. Or x.
That makes sense, yeah.
Oh! You open the door, the light goes on.
You mean
You
you?
said you. Unless you don't, you got how.
It's you, Mr. Grady.
Is it the end of the world that I switched it to an X?
Yes.
No.
Yes.
Get over it. Okay? Now,
Well, that's you.
oh, it's true, and that's kind of punny.
I'm hilarious.
Or something. Now, in this case, that 2x squared, once again, is just going to come along for the ride. Okay?
Yeah.
So you have 2x minus 5, 4x squared, plus 10x, plus 25.
Yeah.
Yeah,
Let's go with that.
That's as goofy as this gets for right now. Because some of these perfect cubes will be hiding within. So you just have to take a quick look and see if you can find out where they're at. Okay? I have 8 of these to look at. So what I want you to do tonight is it's on section 6.4. It's page 349. 33 to 40. Okay. I want you to do those 8 of them, please. It should not be that bad.
Exact answers out of these cubes.
Not always.